Hello friends, today we are going to see finite automata with epsilon transition. So why it is used and how it is used, that we will see in the coming slides. First we'll see what is finite automaton with epsilon. It is an extension of finite automaton. The new feature that is we allowed in the transition is epsilon. Epsilon, as we know, it is an empty string. In effect of NFA, non-deterministic finite automata, we allow to make a transition simultaneously without receiving an input symbol. Here underline the word without receiving an input word. Means here earlier we are not considering epsilon as an alphabet set. Now in NFA with epsilon, we are considering one of the input as a empty string. Without consuming any energy, we are moving from one state to other state. Then next one, why to use the epsilon transition. We shall begin with the informal treatment of epsilon NFS using transition diagram that allows epsilon as one of the label. However, each epsilon along with the path is invisible. That means it is not necessary to mention that transition over the epsilon. Even though it is not mentioned, it is implicit. That means it contributes nothing to the string over the path. For instance, NFA recognizes the keyword webs and EB. Let's say, take one example. Here, this is one of the states, starting state. We can call it as the arrow is pointing to the state. That means this is the starting state. Now, without consuming any energy, I may switch to the state 1 from start state, or from this number 9 state, we can directly move to the 0th state without consuming any energy. That means over the epsilon. Right, over alphabet set, it may be anything. Binary number 0, 1, alphabet set A, B, likewise, anything may be alphabet set. Over its empty string, I may switch from first state to the from one state to the other state. And see, we are talking about the web. So on in the state 1, if I got W, I will switch the state in hope that I will read the next symbol as a E. And we are switching, once we read E, we are moving from state 2 to state 3. And again, in a state 3, if I got B, I will switch to the accepting state, because we got the expected output web here, right? And now another word was bay. So eBay, sorry. So on the 0th state, if I got first E, I will change the state, and then in a hope that I will get next B. Once I get the B, I will switch to the next state. And again, in this state, I am now hoping for the next A. Once I get A, I will switch the state again. Now we got the partial string E, B, A. Now we are hoping for the next character will be Y. Once we get the Y, we'll enter into the accepting state. See, in this example, I want to search two things, web and the eBay. So directly without we can draw the NFA or a DFA. So we have seen that at this moment, initial state, without consuming any energy, we can switch to the two different states. With the help of DFA, this is also possible, but with which contain a lot of states. And with epsilon, this becomes very easy to do this transition, right? Now, we'll see what is the formal definition of epsilon NFA. What do you mean by epsilon NFA? It is same as that of the NFA only. We may represent epsilon NFA exactly as we do an NFA, with one exception. That means we are including epsilon in the alphabet set. The transition function must include the information about the transition on epsilon. So our alphabet set is now sigma union string. That is the only change in the definition of epsilon NFA. Otherwise, it is same as the 5 tuple Q sigma delta Q0F. As we know that Q is a set of finite state. Sigma is set of input alphabet or input symbols. This is delta transition function which remains same for the epsilon NFA as well. Now, along with the empty string as in one of the input symbol. And Q0 is the initial state. F is a set of final state. Now we will see few more examples how to do or how to design epsilon NFA. Where may I apply the epsilon NFA? Whenever there is a parallelism, as we have seen in the previous example, we are doing the parallel things. I am searching for web at a time. I am searching for the eBay string. This is how we are achieving the parallelism in epsilon NFA. Let's take one more example. We have to design an NFA, draw or design an epsilon NFA that accepts decimal numbers, which consists of an plus or minus sign, the string of digits, decimal point, and another string of the digit. Either the string of a digit or the string 2, we can say, can be empty. But at least one of the two string of the digit must be non-empty. This is what our problem statement. Now let's see how to design the epsilon NFA for this. If you understood the statement, here we have to first define the machine. So suppose E is our machine, then how many states should it contain? What are the input alphabet set? What is the initial state? What is how many final states? And what is the transition function? Transition function is very important here. Now, as we say, input alphabet set, it contains decimal, plus, minus, and the numbers 0 to 9. Decimal numbers means base 10 numbers. That is what 0 to 9. So these many inputs we may get as a symbols while reading the string from starting to the end. So suppose I start at the state Q0. I may read first epsilon, so I can change the state. On read nothing, we will change the state. And if I got plus and 1, plus or minus any symbol, still we are going to change the state. That is Q1. And here, if we get any number of zeros or decimal number 0 to 9, we will remain in the same state. Because we have to accept the first part of the string, any number of digit. So there is no need to remember which digit is there, right? We have to remember there is a decimal point. So once I get the decimal point, I have to remember it. So we will change the state to Q2. Now again, after Q2, there may be a string. So there may be 0 to 9 numbers. Anything we will read, we will switch to the Q3. So this is the second part after the decimal part. We have to remember. Fine. So again, after reading that, in that state, I may read any number of 0 to 9 numbers. And at the end, it may be any numbers or after epsilon. Because this epsilon we are thinking for the, as per the condition given, if epsilon is there, we are going to accept the string. Right? Now here, in between, we have introduced another string. Before starting, there is after epsilon, there may be digits. Right? Without plus minus or plus minus, if it is there, any number of strings, then we will remain there. Actually, is there a need of introducing this string? Yes. Or it depends upon the input, right? So here in this case, we are using how many states? Q0, Q1, Q2, Q3, Q4 and Q5. So this is my Q, capital Q, set of finite states. Now, this transition diagram can be converted into transition matrix like this. As we know that rows are states, columns are inputs. So what are the states? Q0, Q1, Q2, Q3, Q4, Q5. So which one is the starting state? I forgot to mention here start and the star symbol. Here Q0 is the initial state. So we are supposed to point to arrow here. And Q5 is the final state. So it should be a star. as we did in the DFA, right? Now, epsilon, what are the input symbols? As it is epsilon NFA, epsilon should be there, then plus, minus, any operator, then decimal point, and then any digit 0 to 9. So, on the zeros, I will switch to the Q1 on epsilon and plus 0, right? So we are moving from Q0 to Q1 on epsilon. We are moving from Q1 to Q0 to Q1 on plus minus. Likewise, we will complete the matrix. So now we will see, this is how we have seen the complete epsilon NFA. So before starting to that, if anybody have a doubt, you can ask me. Right? For today's session, I have referred John Hofcroft and Ullman's reference book. Thank you.